Morning to all of you. Behalf of the UGC HRDC Dr. Babasaheb Ambedkar Marathwada University Aurangabad, ongoing online refresher course in environmental science, environmental studies, and sustainable development, interdisciplinary course. I'm roll number 24, Dr. Kelkar Gautam Dashrath from Zamkhed Mahavidyalaya Zamkhed. My main subject is geography, and in this refresher course, I'm my micro teaching topic is atmospheric pressure and wind system. Roll number 24, Dr. Kelkar Gautam here present micro teaching topic on atmospheric pressure and wind system. What is the atmosphere and what atmospheric pressure? If you see the introductionally, when we observe the atmosphere, there are certain uh, amount of air pressures. So it is called as to the atmospheric pressure. It meanings of the air pressure. Meaning of air pressure. When we live at the bottom of the atmosphere, at the weight of all the air above us is called as to the air pressure. It is called as to the air pressure. This is the main meaning of air pressure or to the atmospheric pressure. It is exact force on unit area, and atmospheric pressure is equivalent to the weight of air above a given area on the Earth's surface or within its atmosphere. This called as to the atmospheric pressure. Is also defined as the force per unit area exerts against a surface by weight of air molecules above the Earth's surface is called as to the atmospheric pressure. In this diagram, I explain the what is atmospheric pressure. This bar is show the unit areas, weight of air in column of pillars as pressure to X point of the unit area, surface area is called as to the atmospheric pressure. The weight of column of air contained in a unit area from the mean sea level to the top of the atmosphere is called as to the atmospheric pressure. If you see the air expand when heated and gets compressed when cooled, this result is variations in the atmospheric pressures. So that the result is that caused to the movement of air from high pressure to low pressure. The colded air have getting the more weight, so it is called as to the high pressure area, and where the heat was the air was heating, so that it is the less in weight, so there is created for the low pressure, and the result is that the cause of movement of air from high pressure to low pressure area. Sitting there, air is motion in atmospheric pressure is also determines when the air will rise or sink. The wind redistributed the heat and atmospheres across the plants, thereby maintaining the constant temperature from the planets as a whole. The vertical rising of motion here cools it down from to the clouds and bring a precipitation. How to measure the atmospheric pressure? Next point is that atmospheric pressure is measured by to the instrument is known as to the barometers. Especially these barometers are two types, the mercurial barometer and the aneroid barometer. In these two instrument, you are measure the atmospheric pressure. The parameters of atmospheric pressure measurements either in inches or centimeter. दोन्ही याच्यामध्ये तुम्ही मोजू शकता. ॲटमॉस्फेरिक प्रेशर इज expressed in several different systems of units, millimeters, inches of mercury, pounds per square inch, psi is called as to the psi, and dynes per square centimeters or millibars. Uh, the standard atmosphere or to the kilopascals is also the measurements of the atmospheric pressure. Standard sea level pressure by the definition equal to 760 millimeters is called as to 29.92 inches of mercury. If you consider pounds, 14.70 pounds per square inches, it is ratio 1013.25 into 130 dynes per square centimeters. It calls 130.25 millibars. One standard of the atmospheric pressure is called as 1013.25 millibars or 101.32 kilopascals. Variation about these values are quite small, but both are considered to the standard atmospheric pressure. Especially the normal value of the atmospheric pressure at the sea level at latitudinal 25 degrees accepted as 29.92 inches or is considered as the 760 millimeters or mm. Recently, another unit of measurements has been introduced in metrology is known as the millibar. Since pressure is force, it is appropriate to measure in millibars, and hence it has been adopted by weather bureaus. He's recently introduced the metrologies under the metrology department. The pressure measurements unit is millibar, and today's is a worldwide use. 1 inch of mercury is equivalent to 33.9 millibars. Inches mercury. 1 millibar equals to 1000 dynes per square centimeter, or in kilopascals, 1 kilopascal is equals to 10,000 dynes per square centimeter. It is the measurements of atmospheric pressure. Second thing, distribution of pressure on a map are depicted by the series of curved lines. If you see the map, the atmospheric pressure is shown by to the lines. This lines is called as to the isobar. Each of connects points on equal pressures area. Especially if you see on the map, there are some equal areas of pressures. For example, 100 millibar, 100 millibar, 100 millibar. This 100 millibar, all points are connected by to the one curved lines or to the one imaginary lines. This imaginary lines is called as to the isobar, and this isobar shows on map by isobar lines. If you see what is the air pressure on sea levels, at the sea level, the mean pressure is about 1000 millibars. 1000 millibars equal to the 100 kilopascals. It is varying by less than 5% from this value at given any location or to the times conditions area. If you see near the Earth's surface, pressure decreases with height at the rate of 3.5 millibars for every 30 meters or 100 feet area. If you go along to vertical sides from to the surface of the Earth, the pressure decrease ratio is 3.5 millibar for every 100 feet or maybe 30 meters. Over cold air, the decrease the pressure can much steeper because density is greater than to the warm air. So that the pressure at 2,70,000 meters, 10 millibars, is comparable to the that is the best man-made vacuum uh, ever attained at the height of above 3,000 meters. It is called as to the approximate 1,000 feet. Uh, the pressure is low enough to the produce mountain sickness and serve physiological problems unless careless accumulations acclimatizations is undertaken. So it is the uh, atmospheric introductions. What is mean by atmosphere and atmospheric uh, measurements, etc. Next thing, vertical distribution of atmospheric pressure. In normal conditions of the atmospheric pressure are maximum at sea level, but the atmospheric pressure decreases with the increasing in altitude or to the height. It does not always decrease at the same rate everywhere at any regular or to the fixed rate. It means that when you go in vertical manners, the atmospheric pressure decreases with increasing height. But the ratio of decreasing is not uniform overall universal area, because the local factors is also responsible to decreasing the ratio of atmospheric pressure. So that it is the most important thing is that it is not always decrease at the same rate everywhere. It means seen when you go internal parts of the earth, sorry, you go the interior areas means continental areas, there the temperature in the daytime is increasing, so that the decreasing ratio may be in continent area is high as comparison to the wet area or to the humid area, because the ratio of decreasing at the same rate everywhere or at any regular point is not fixed. Second thing, air is highly uh, compressible. The lowest layer of the atmosphere are the dense because the weight of the air lying above them. Hence, atmospheric pressure is always maximum at sea level area. Uh, Above sea level up to an altitude of 2,000 meters, the atmospheric pressure decreases by 1 inch or 34 millibar with every 300 meters. At higher altitudes, the air rapidly becomes thinner and thinner, and hence one half of the atmosphere by weight lies below the elevations of 6,000 meters. Is that the rate of decreasing in atmosphere becomes lesser with an increase in altitude, and beyond an elevations of 15 kilometers decreases extremely slightly. This is the graph. It's showing to the atmospheric pressure is decreases with increasing of height. If you see in this diagram here, approximate 100 meters, uh, approximate 13,000 meters, the atmospheric pressure is very low. It is near about 15 to 60 millibars. When you comes downsides area below 5,000 height, below 5,000 meter heights, there are pressure distribution uh, is higher as comparison to 30,000 meter heights. So it means the atmospheric pressure is always decreases with increasing of the height. This again, this is show the diagram of atmospheric pressure is decreases with increasing the height. Next point, factor influencing vertical distribution of air pressure. The first one I told you just altitude. Altitude, it means height. When you go in vertical height, that time above the from the sea levels to the higher area, higher altitudes area, the atmospheric pressure is decreases with increasing the height. This is the one altitude. Second one, temperature. Temperature also is a second responsible factor to distribute, to influence the air pressure. If you see, the cold air is getting higher weight, so that there's a high pressure. When the air heat, air warm, temperature increase, so that time the air is warm and air is expand, because the weight of air is reduced, so that it is move the vertical manners, and the increasing with temperature, the pressure is also decreases. Next is water vapor. When the atmosphere areas, the vapor content is highly presented, so that time is also air pressure is high. If the water vapor is not presenting in the atmosphere, that time air pressure is low. It is the some factors to the influencing of the vertical air pressure distribution. Second one is horizontal distribution of air pressure. Atmospheric pressure is largely depends on the temperature of the air, the amount of water vapor present in it, and the distribution of land water. Hence, the horizontal distribution of temperature pressure is highly uneven. This is shown on the map with the help of isobar. An isobar is lines connecting points that have two equals value of pressure reduced to the sea level. Isobaric map show that there are certain belts or zones where the atmospheric pressure is high, while in among the certain zone it is low. These are the diagrams to show how the horizontal atmospheric distribution is seen. But these high and low pressure belts are not altogether permanent. They are greatly influenced by the apparent seasonal migration of the sun and the variation in heating of a large and masses of the water bodies. According to this atmosphere belt, pressures, there are belts are formed. The pressure belts are creates on the Earth's surface. The certain areas of zone are over which is the atmospheric pressure tends to be above the average such zone are known as to the high pressure belts, while other areas atmospheric pressure is below the exact average. These zones are known as the low pressure belts. These pressure belts are not permanent. They are migrant north and south pole throughout 5 latitudes due to the appearance of the migration of sun. They completely disappear in particular season over large land masses of the northern hemispheres or to the certain area. For the study of these pressure belts, where a generally arrangement is taken at the time of equinox when both the hemispheres receive the same amount of insolation, it is also assumed that the earth is completely covered by water. The atmospheric pressure belts envelop on the surface of the earth. They are equatorial low pressure belts, subtropical high pressure belts, and subpolar low pressure belts, and polar high pressure belts from the equator to the poles. Each hemisphere has 4 pressure belts. At the totally, there are 7 belts on the globe's area or to the present on surface of the earth. The pressure belts lead to formation of primary winds and secondary wind. This diagram you see, this diagram shows the pressure belt formation. Just I am told you to 4 belts in north hemisphere, four belts for each hemisphere, not only north hemisphere, south and north hemisphere. They are the four belts. But overall, totally, if you count, it is are the seven belts. The equatorial low pressure belt is the common for to the north hemisphere and south hemisphere. So that is when you count the separately hemisphere wise, the four belt in north hemisphere and four belt in south hemisphere. But when you globally count, the total air pressure belt is 7. The equatorial pressure belt is considered as a 1 when you globally count. Otherwise, it is the considered as the separate. In this diagram, we see the pressure belts. Where is the form low pressure belt? Where is the form high pressure belt? Where is the again from the high pressure belt or low pressure belt? There are the certain causes to the formation of that type of the belts: high pressure, low pressure, high pressure, low pressure belts. Equatorial name is suggests equatorial doldrums, or so it is called as to the equatorial low pressure belt. Next, sub polar low pressure belt. These are the polar belts. Reason of formation of these special belts: first one is the equators. Second reason is poles and dynamic, including axial rotation of the earth. These are the three main causes to the form of the pressure belts on the earth or to the earth globe's area. We see the details about this pressure belt: equatorial low pressure belt, the subtropical high pressure belt, the subpolar low pressure belt, and the polar high pressure belts. When you see this diagram, sorry, it is not seen the diagram. Equatorial low pressure belts. This belt is lies between 10 degree north to 10 degrees south. If you see on this diagram, just wait a minute. These are the equatorial low pressure belts area. When you see this red line, it is equator, and equatorial pressure belts area extend 10 degree north to 10 degrees south latitudes area. They are the forms. Although its width maybe varies between 5 degree north and 5 degrees south and 20 degree north and 20 degree south due to the intense heat. It is related to the zone of maximum insolation. This area is receive the maximum insolation on Earth, so that it is extend up to 20 degrees 20 degree north and south sides latitudes area. The angle of sun rays is 1 degree always more than 66 degree half, and hence the temperature here is high throughout the year on that equatorial belt, so that it is formed to the low pressure belts. The sunshine is always vertical on the equators throughout the years. As a result, the gets warm and rise over the equatorial region and produce equatorial low pressure. This belt is characterized by to the extreme low or to the calm conditions on the Earth's surface area. Further, due to the high temperature, the rate of evaporation is also intense in that equatorial low pressure. The belt experiences sticky heats due to the extensive heating. Horizontal movements of air is absent here, and only conventional currents are there. Therefore, this belt is called doldrum, the zone of calm belts. Surface winds are generally absent, since winds approaching these belts being to be rise near its margin. Thus, only vertical currents are found. This belt happens to be the zone of convergence of trade winds from two hemispheres from subtropical high pressure belts. These are the region to convergence because the wind flow from subtropical high pressure belts to the belt is also known as the intertropical convergence zone ITCZ. This diagram, you see the equatorial low pressure belt, subtropical high pressure belt, and polar pressure belts. It is the condition that uninox, summer solstice, anemometal, equinox, vernal equinox, etc. Thank you. It is a micro teaching topic. There are